Good afternoon. And thank you all for coming to listen to my talk. Today I'm Clem Lau, and I'm with Bright, Sales Director for Asia Pacific in Japan. And today I hope that I can share some ideas with you that may be useful. So today really I want to talk about the 3 R's of cluster management, and especially hybrid cluster management. So this is something that sometimes happens. Maybe your system administrator looks like that sometimes because of stress that they get. So what we would like to get to is a stress-free zone. So IDC, they have a report every year, but twice a year. They have the report once at ISC, and then they have a report again at the SC, supercomputing in the US. And in the report, they said for 2 years in a row, they've said that clusters are still hard to set up and operate. New buyers need easy everything. There's a shortage of skilled people to help you run your cluster. That's a major problem. Software is the #1 roadblock, continues to be the #1 roadblock. And so the conclusion is that better management software is required. So the problem, why are clusters so difficult to manage? Well, clusters need all of this. Deployment, provisioning, updating, all of this they need. What makes it hard is that everything affects everything, as you know. Everything changes all the time. Hardware breaks. And then you need to add cloud services, so that increases the complexity. So that leads to IT downtime, delays, and inability for IT management to react to the situation. So that all causes stress. And then what happens is many people use different tools to try to hold together the cluster, to do the management, to do deployment, to do different pieces of what you need to have the cluster working. And then what you end up with is this spaghetti mess. So again, some of the causes of the stress that the system administrators find is that there are many users with different requirements using the HPC cluster. So for example, different user groups want to use different CUDA SDK versions. Very often, one application works on the old SDK, and another application only works on the new SDK. So how do you manage to give the different SDKs to the right user groups? There's also high stress level when there's a system problem, and then the users are calling you to report the problem. And then you continue with the stress until you can find and fix the problem. So what happens very often is experienced HP analysts and system engineers, they spend a lot of time managing the cluster and keeping it running, and not enough time to help users to maximize their productivity. So these experienced HPC people that are hard to find end up to have low job satisfaction because of all the stress and all of the time they spend on doing just management, system management work. So how can we help to reduce that? Well, one of the ways is we provide an intuitive and a single pane of glass solution to cluster management. And then also to provide a robust and integrated system monitoring system into the management solution. so that the administrators are now the first people to know when there's a problem. So what Bright Cluster Manager provides is a single pane of glass, as I mentioned just now, where the cluster's resources are here on the left of the screen. And then we have uptime, we have utilization, we have the queue situation, workload manager situation here, because we are integrated with many workload managers. And then at a glance, monitoring metric. So it could be anything that you choose. Could be the CPU temperature, could be disk speeds, could be anything. And then at the bottom, we provide the event logs. So all of the event logs are collected on this single interface. So it's a very quick way for the administrator to see what's happening with their system. For GPUs in particular, we do some special integration. And we work very closely with NVIDIA and NVIDIA's people so that we have new versions of our software to match the new versions of the hardware coming. In the software area, we have everything that you need to enable your GPUs. The drivers, the CUDA, OpenCL, environment modules is very key for HPC users using environment modules. It's to make sure that your users have the right setup, easy switching between CUDA versions. So this is the kind of environment control that we bring. We have integration with workload management so that the GPU is automatically added to the workload manager queues, and it's easy for the users to use. And then in terms of the management of the GPUs, we have easy setup wizards. GPUs are easy to use and manage. They show up on the left-hand side of the GUI panel that I showed you just now. Then they can be configured through either a GUI interface that I showed you or a command line interface. We support multiple GPU units. And then the other thing that I mentioned in that one pane of glass slide is that integrated monitoring. So we have integrated monitoring and health checking for the GPUs. Sorry. So this is what we do for GPU management. And then some special things that we add in are configuration options. That's easy for you to go and set. Plus we have NVIDIA HealthMon based health checks that make sure that the GPU is working correctly before you send jobs to it. And I'll talk about that in a few minutes. So a little bit about Bright before we continue on. So Bright is a software company founded in 2009. We started off with bare metal provisioning, but now for HPC, including GPU clusters, of course. As we heard earlier, many of the supercomputers now have GPUs or accelerators of some sort. But we also have capability to provision, deploy Hadoop clusters and Openstack private cloud. So we're unique because we are the only software solution that integrates all of this functionality into one platform. So we're backed by venture capital funds, and we have had some good success, commercial companies as well as academic institutions. So we have lots of resellers around the world. HPC Tech, that's here at the exhibition hall, is one of our reseller partners here in Japan. The company is founded and headquartered in Amsterdam and has a US operation as well. So we've also won a number of awards because of our uniqueness. So just to summarize, over 10 years, we've got over 400 customers. We provide a single pane of glass. And this point is quite important for users, is we're vendor agnostic. That means you can use Bright Cluster Manager on any x86 Linux machine. The other thing is that is key for many people in HPC data centers is multi-cluster capability. So in the top panel just now with the GUI that you saw, I can choose and manage multiple clusters in different locations and in different geographies. So I could manage from Tokyo, I can manage a cluster in the US, I can manage a cluster in Amsterdam. So this or I can manage 3 clusters in my local data center. So this is a very critical functionality for a lot of users. Obviously we support accelerators, and today we're scalable to 10,000 nodes. By next year, we'll be able to support exascale, hundreds of thousands of nodes. This is a picture of the integrated monitoring. Another visualization method is this rack view, where it's very easy to tell exactly where in your computer system, the rack, which slot has the problem. And then this one is just to show it's small, but it's the GPU metric, so it's the same for GPUs. Very, very easy to use, very easy to spot. In fact, for monitoring rules, we have a very easy template where if you can enter in a Linux command to retrieve a number, we can turn that into a metric that can be inserted here, and then that can be measured and displayed as you saw earlier. So then your system administrator now looks like this, much more relaxed, right? This is much better than the first picture. So, but we want to reduce more than just your stress. We want to cut your energy costs. Why? Because 50% of the cost to run a data center is in the power consumption. So Bright has a tool that allows you to manage the power consumption by putting nodes to sleep, adding and deleting nodes, especially in a private cloud environment or in a virtual environment. We can stop or terminate nodes if there are no jobs in the queue that require them. So that helps to save energy. So now I want to go into the second R, which is increasing. Increasing what? Increasing your efficiency levels, increasing your uptime, increasing profits. Now, when we say increasing profits, it means a lot of things to a lot of different people. So it's really increasing your ROI. And your ROI consists of what? If I'm a researcher at a university or an academic research lab, it's faster research results. I have to publish. Everywhere in the world, it's the same. If you don't publish, you don't get funded, then your research has a big problem. For companies and for product manufacturers and whatnot, faster time to market. That's my ROI. I want to get there faster, because if you're the second guy to bring that to market, then obviously, it's going to be, you're not going to make as much money. And then for companies, it's really making more profits. And so some factors that help you to increase your ROI are reducing the time that it takes to deploy your cluster, get my machine up faster, reducing the amount of effort required to maintain and monitor my cluster, right? So then that comes in 2 parts. One is that during the normal operation, and then the other one is also in identifying problems, as we saw earlier. And then this last point, reducing the downtime or increasing our uptime. So this is a quote from one of our customers at Boeing, one of our biggest customers. And what's important is that it reduces their node provisioning, and you have to provision your node every time you boot the node, right? So it has to run an operating system, has to be managed. So by a factor of 10. And it's done with a few mouse clicks. Easy to use, fast, reducing his downtime, increasing his uptime, increasing his efficiency, and lowering the amount of effort that it takes. One of the key things in provisioning and making sure that everything is working the way that you want it to work, at guaranteeing job execution environment, is that you can see here one of the very strong points of Bright Cluster Manager is this image management. So you can see here I've got 2 nodes that are running the green image, and then I've got a node running the blue image and a node running the red image. So this could be a particular environment that I'm usually running in HPC. This maybe is running a version of the current version of the CUDA SDK. This is the newest version of the CUDA SDK for testing or for a user that requires that. So Bright Cluster Manager ensures and guarantees that there is no node drift. That means the nodes have exactly, those nodes that have the same image have exactly the same image. There's no node drift. And then the nodes that have to have different images have the correct images. So increasing efficiency, I mentioned a little bit another problem that I want to talk about here. So this is the problem. Or another picture of that is this, the black hole. So the black hole node syndrome is something that gets more serious as you get to be having bigger jobs and bigger size machines, especially if you have hybrid machines with GPUs and CPUs. And so what happens is that a simple thing, apparently healthy nodes, it's not a bad node, it's a healthy, maybe the file system got dismounted, so you don't have the right library or something. So the workload manager sends a job to that node. The node says, oh, I don't have that library, sorry, exit. I'm free for another job, give me another one. Gives them another one, oh, sorry, exit. Oh, sorry. So then your queues are drained completely, just like a black hole. There's cluster is idle, is doing no work, and nobody has any results. Horrible. So this is something that is very serious and gets to be more complex. So Bright Cluster Manager, we can do some pre-check jobs. We do a pre-job check even before the workload manager's pre-job script. And so we can do some simple checks to see if that node has everything that it requires to run the job. So if it fails, we tell the workload manager to mark that job offline, that node offline, and don't use it, and then we'll send the administrators a notice. So we've talked about how to increase your ROI. However, change is inevitable, as we know. So change is always happening. The place changes, you get new ideas, So we want to help you prepare for change. So the 2 biggest things now in the HPC environment are Hadoop and Openstack. With Hadoop, we bring the same easy installation, the same single user interface, the same easy setup and management, and we support all of these Hadoop distributions. What's new is Intel IEEL, and so that you can have just Lustre to run your Hadoop as well as your HPC. We have specific monitoring for Hadoop. We also have integration with the workload managers. And all of this is automated from bare metal. So you install Bright Cluster Manager with your new machine, click on the Hadoop button, and then you go through a few configuration screens, and you can have the Hadoop. The other big thing that's in HPC now is OpenStack private clouds. Lots of data centers want to incorporate private clouds so that they can offer their users cloud-like services. Bright is now an OpenStack-powered partner, which means that we can distribute, and we do distribute, OpenStack with Bright Cluster Manager. So you don't have to go and find an OpenStack distribution, download it to install it and everything. So we have everything on one CD or on a USB stick. We have the same single pane of glass, same management. You see OpenStack, just like Hadoop would be, comes up here on the resource panel on the left-hand side. You click into it. You can manage it, configure it. Event logs down here, the same thing. Easy to use, easy to manage. So in summary, try to accomplish and help you to achieve is you have a bunch of servers, bare metal. On top of the servers, you run Linux or some kind of operating system. On top of that, you can put in Bright and Bright Openstack. And then we have our homegrown, lightweight daemon running in this environment. We install HPC modules on there, which includes all of the user environments and everything like that. We can put a big data environment on top of that. Others, web servers, other services. Then we put the OpenStack private cloud. And so, but what do you do in an OpenStack private cloud? You have virtual machines. In the virtual machines, you run operating systems. And then on the operating systems, if you run Bright Cluster Manager's daemon in that, then now we can manage them and look into them. Just unlike OpenStack that can set up the virtual machines, it can't help you manage and look inside the virtual machine. So we can help you to look inside the virtual machine, manage that, deploy it, all that kind of stuff. And then we can, in that cloud environment, put in the HPC, put in the big data, put in the web services, and then put in the private cloud. So you can run private clouds on top of private clouds. So we've been doing this internally for 2 years. And so all developers can have their own cluster, and then they can go off and do whatever they want. So this gives the end user or you to have the best of both worlds. You can have a real physical environment here with GPUs and whatnot, or you can have the virtualized. Some jobs run well in a real physical environment. Some jobs run well in a virtualized environment. So you can pick best of both worlds. And then now we provide cloud bursting also to AWS, which I didn't talk about today. But we provide that also in the easy-to-use manner. So that's the 3 R's of cluster management. Thank you very much for your time and your attention today. And if you have a chance and you want to read more, there's Inside HPC. On their website, there's new strategies for managing high-performance clusters, GPU clusters. And it's quite an interesting paper to read. So thank you for your time.